on our panelists. We have Greg Livingstone from Fluitec helping us out
Hello.
with this panel, Robert Torres from Amber Industrial Services, and of course, Jim Hannon from ExxonMobil. So we have these three amazing experts that are going to be telling us a lot more about, preparing your lube system for a turnaround. And we know turnaround season is coming up. So I know these guys are going to be giving us some more information, what we can do, what we cannot do, what we should do, and what we definitely should not be doing. And I'm going to pass it on to all of them because they are the experts here. I know Greg wanted to share a couple of slides this morning. So I'm going to pass it over to Greg, and Greg can kick us off on, how do we even begin preparing for a turnaround, especially with your loop systems? That's the heart of it, definitely.
Excellent. Good morning, everyone. Nice to see you all. And I think one of the points that I wanted to make is that when engineers are planning for a turnaround, typically they're looking at 12 to 18 months out, and they're looking at kind of a long-term plan. And so there's a tremendous amount of planning and project management work involved in organizing a turnaround. It's a very, very stressful time during a plant's life, during turnaround time. There's a lot of engineers that are getting very little sleep. You also have a lot of other contractors on site. So it's a very busy time. So I think from a lubricant point of view, the more forecasting you can do to be able to better predict what services may be required, what action may be required, I think would be, I think is super beneficial in the planning process. A lot of times we see lubricants are kind of something that is maybe overlooked in some planning, and so it's a few months prior to the outage, and people are like, well, what options do we have? The oil's in bad shape. Do we have time for an oil change? And so it's a little last minute scrambling. And so I always think it's good if you consider your lubricant like an asset, like all of the other assets that you're trying to maintain during your turnaround, then you should have the same kind of forethought with what action should be taken during the turnaround. So maybe that's my introductory. But before we talk about this slide, maybe Robert and Jim can kind of go through and give their view on this here as well.
I'll just offer a quick build on that. It's really important to have regularly scheduled meetings with your lubricant supplier so that you've built a rapport and an understanding of your equipment and their what they can bring to the table. And like this slide, it is a very complicated slide with a lot of different paths to take on it. And it's not meant to study and follow these paths, but the key elements are over there on the left, those key seven elements. And we feel like if you've got a good handle on these key points, then you're going to be in a very good position to understand what is your best path for that particular turbine at that particular time in the oil and the turbine's career. So and then we can go through that in greater detail later, but that just kind of sets the stage for the meetings that you should be having with your oil supplier on a regularly scheduled basis, and then you map out, maybe the plant has got 6 turbines, and you'd say, okay, turbine 1 is at this stage, and you go through each one, but you develop a holistic plan.
Yeah, I would agree as well. I think creating a really good, deep understanding between, your plant, your staff, your crew from the get-go, I think sets them up for a really good position to succeed. I think a lot of times before we even get to the maintenance strategies and in-service oils, it'd be a really good recommendation to sit down with your staff and say, look, turnarounds are stressful, right? Prep them. List all the negatives. Say this is going to disturb our operation. We might need to order extra parts. They're not planned for. The additional maintenance costs, there are a variety of aspects that even might contribute to the risking of safety. So after you get all those negatives out of the way, sit down with your staff and say, look, this is a planned shutdown. This is something that has been forecast out so that we can improve the efficiency of this plant. You would rather have a planned shutdown than an unplanned shutdown, obviously. And I think also try to catch the potential failures ahead of time. So if you're prepping your staff and making them really aware of that, I think it puts them in a really good mindset to be acceptable to a lot of change, because it is different from their normal standard shift.
Oh yeah, I love that. Definitely love that, Robert, because I think everybody going into a turnaround, there's always a little bit of anxiety of what can go wrong. And we know a lot of things go wrong. But being able to plan in advance and preparing yourself for that, that helps quite a lot. And I like what Jim said as well, in terms of we know it's not a simple operation. It is complex. It is a lot of moving parts involved. So it's easier to just take it bit by bit. So I'm going to pass it back to Greg and help us go through this very easy looking slide that you have there.
Well, this is far too complex for me, so I'm going to pass
Oh,
this on to Jim with the.
oh yes,
See,
definitely. Pass it on to Jim. Yes.
the flow chart is very complex, so we'll have the expert answer that.
And then just to say that, so Greg and I, and then Rig, put this together, and we worked on this quite a bit over the last couple of years to figure out just kind of that as a customer is sitting down to figure out, okay, I've got a turnaround coming up. What do I need? What do I need to prepare to understand what my actions should be? And really the key elements that to sit down, you have to take a look at, oil analysis. And when I say oil analysis, it's got to be advanced oil analysis. It can't be simplistic like just viscosity and acid number and water. We want the full test late. So that includes, and we've got more slides on it later, but that includes, your ruler numbers, your MPC numbers, your ultracentrifuge numbers, your FTIR for oxidation, your RPVOT, and a whole list of probably a total of 12 different tests that we want to see. And it's often best to get a trend of it, not just a one-time data point. And that's why the continual building of data and relationship is important. With all that, then you've got a pretty good start on things. And then we would look at, if you have the capability of doing equipment inspection. And oftentimes you don't, because the equipment's up and running. But there are times when the unit is down, and especially in those, like a GE turbine, where you can pull a servo valve and do a servo valve inspection or a last chance filter inspection. And or you could be studying your bearing temperatures and watching for any climbs in bearing temperatures. That's all kind of indications and could be captured under equipment inspection. Then we look at the oil service life hours, because we have a pretty good idea on the oil life expectancy. And so oftentimes it does get lost in the details about, well, I've got 34,000 hours on that oil. Okay, that tells us a pretty good story. Or I'm at 90,000 hours on that oil. Well, that tells us a different story. So really understanding those service life hours, maybe if there's a lot of makeup, understanding the makeup rates. Then also certainly understanding the in-service oil that's being used. And sometimes it's actually two different oils because of whatever reason, you might have two different oils in a reservoir. So understanding that. Also understanding operational issues. Am I having bearing temperature issues? Am I having a hydrogen seal temperature issue? Am I having sticky servo valves? All those kind of things, and then photo documentation of that is also very helpful. Then also understanding your operating profile. Are you cyclical or base loaded? And also, what are you going to be doing in the future? More base loaded, because if it's more base loaded, maybe you have less of a problem with sticky servo valves. And then lastly is that outage schedule. Okay, we're going to be down now for a major overhaul, and we're going to be out for 3 weeks. So we can do all this stuff, or in the next 18 months, I've got a hot gas pass inspection where I've got 4-day window. So all of those things build into eventually going through that turbine oil triage.
Good. I love that explanation. It's very important to plan in advance. And I think being able to know what you have and what you're working with, that helps a lot. Your planning engineers are very important there, and especially your finance team, because they need to help us out with the budget parts. Anything else you all want to add for that, Robert or Greg?
Robert,
Sure.
Okay, I'll let you go.
Yeah, one quick thing that James touched on was the documentation piece. I think is vital. I think the two major purposes for a planned shutdown would be to either correct some of the problems identified on the previous shutdown, or to possibly look into the next shutdown and what are the identifiable markers that need to be documented for the next shutdown as well. So when James touched upon details, I think that's a perfect example of documentation. You'd be amazed how much data you can grab from your cell phone, and operators and engineers can then regroup together during the shutdown in progress meetings on status updates, and then attention to detail. Those are going to be really, you're saving facts, because really on a shutdown, you want to catch your low-hanging fruit first and then get to your more difficult systems. So when doing so, it's really documentation piece, and really pictures and all these reports are going to be vital.
Mm-hmm. Definitely.
So one of the things that I think is we always get a lot of questions from our clients on the oil's at the end of its life. If they're doing a good job in properly preparing for the outage, they know a year ahead of time that in fact they're going to be changing the oil. They can make all the arrangements to bring in a tanker to to facilitate the oil change. But then there's a big question: should we flush a system in between? Should we? Unfortunately, I think a lot of plants actually don't go through this. They drain the old oil, put brand new, beautifully formulated, pristine oil into a dirty, messy system, and shorten the life of it, and it causes all sorts of problems. But I think that's one area that in the loop planning stage that I think is often overlooked. So I think it would be interesting. I think, Jim, I know you have a slide on this, but it would be interesting to get Robert's view on your customers that are considering, should I flush or not, and kind of what some of the different things they think about, in trying to prepare for that.
Yeah, I think one major factor when determination of flushing, or even James had mentioned a varnish, MPC and UC value tests, keep in mind that oil is going to be real happy when it's running at optimum temperature. So when it's running through your system and it is at temp and maintaining temp the entire time, people really fail to understand that when that temp comes down and on that shutdown, adversely, that varnish is going to be a real mess. It's going to adversely change when you go to start back up. Those things have to be assessed and determined, not just at running temp, but not at a running temperature. And then also the data is going to really support all these movements and corrective changes for maintenance. So the MPC and the UC values, they're great data, but it'd be nice to pull those at different timetables throughout the shutdown so that you can have a better understanding and put yourself in the best possible situation to succeed.
Definitely.
Excellent.
Passing it to Jim.
And I just thought maybe I'd advance slides here, and maybe Jim can talk about this a little bit here.
Yeah, and very simplistically, like you said, sometimes you actually if the oil's in good enough shape and you've got reason that maybe we've got our own refineries, right? And they said, look, we've got a turnaround coming. The oil's in pretty good shape. but we need it to last 8 years and we can't touch it. Okay, fair enough. And then it's kind of what the customer goals are, sets your plan forward. But maybe the oil is in good shape and you're just looking to have that extra boost of security. And maybe you'd look at all the data and all the elements of it and say, you know what, we're going to be okay with the drain and refill. But when we say drain, we certainly want to get below 5% residual. And kind of what you mentioned before, Greg, if that system is in bad shape and they just did a drain and a refill, you're going to leave 5% residual. And that 5% residual acts as a catalyst to hurt that next oil that comes in. And oftentimes we kind of see like a half-life. So let's say you got 10 years on the first charge of oil, you did a drain and refill, 5% residual. Well, maybe the next round you'd only get 5 years because you've got those free radicals that are now attacking that oil and making it a lot less, lot shorter service life. So that's the easiest, is just to drain and fill. Or maybe you say, you know what, this oil is in decent enough shape, but I still want to get it out. I'm going to go through a displacement flush. And we have different categories on why you would pick a displacement flush over a different flush. But basically, a displacement flush is draining the old oil out to less than 5%, putting in a charge of oil. It might be the same quality as the final fill, or it could be a flush oil. Those are kind of decisions you would make with your oil supplier. Circulating it on the system, pumped for 8 hours, draining that out, and then refilling, and then with your final fill. Or we've had great success now with the use of mobile solvencer to slash decon to put that in the system 1 month in advance, and then let it run for a month. And we put it in at a 5% concentration. Then we would drain that out to less than 5%. And then depending upon the quality of that oil, and it's a judgment call, whether we would need to do a displacement flush or whether we're satisfied with the work that solvencer has done, and we're now filling with the final fill. So in that perspective, we actually don't even have to go through that secondary flush. So that's an option. And or when needed, you can bring in the sledgehammer, which is, we have a product called Mobile System Cleaner that is a very good cleaner, but can negatively impact the following charge. And you certainly need to go through a very thorough displacement flush after using the system cleaner. And then lastly is a high velocity flush. And that is typically done on new turbine commissioning and or after a catastrophic bearing failure, and you've got to get debris out of the equipment. So there's a lot to talk about there, but those are the 5 types of flushes that you probably may be looking at doing it at any given time.
Yeah, and thanks for explaining that to us, Jim, because a lot of times people go into a turnaround and they think, okay, I need to do a flush, but I have no idea where to start. Like, I'm not sure what type of flush I need to do, what condition my system is in. And that's the thing with these turnarounds. Everybody's system is different. It's not a cookie cutter approach. We have to be able to assess the system that we're working with, the conditions that exist. And I love, Robert talked about it earlier on, documentation. And documentation, that's where it starts really, because if you have no documentation, then how are you going to prepare yourself for this turnaround or the upcoming turnarounds ahead? And that's where it's so important to have this process in place. So I know we're talking about the different types of flushes, how do we assess and what do we do? But what would you suggest to, people who are now engineers who are now coming into the field and may think that TAR actually stands for sticky substance in the ground? What do we suggest to them? How do they start getting on board with understanding how do you prepare for a turnaround? What's the first thing you need to do? And I think the first thing you need to know that TR stands for turnaround. That's just me, ground base level. Yeah.
Well, I think one other thing is trying to pull together all of the relevant OEM recommendations, all of the other relevant specifications. So in terms of the world of flushing, the ASTM D6439, be sure that's right. It's a flushing oil spec. Jim, you and I have contributed to that spec over the years, but it is really an up-to-date methodology on kind of going through some of the different approaches that you would use in flushing. So it's a fantastic resource, I think. So basically trying to gather as many kind of external resources as you can. I think that's an important kind of initial first stage.
Nice. Anything else you all want to add to that, Robert?
Yeah, I think there's a couple of categories. There's a sequence of events in which someone plans for a shutdown and plans for an asset to be either very invasively touched upon or just minimally invasive, where we're just doing a regular PM schedule. One would be defining the scope of work, right? That would be the number one starting point. I think developing a schedule for that definition of scope of work would be the next. You would then have to prepare a budget. I think the other portion that we don't overlook, but sometimes they're just not at the forefront, is making sure that this shutdown is fiscally responsible. Obviously, everyone has accounting personnel that they report to, and we have to operate within, a budget. So at the same time, we want to make sure that it fits the fiscal properties of the actual shutdown, and then communicate that plan to your staff, right? So if everyone has that awareness, then you're able to then execute the actual shutdown based on the plan. And the plan will change. It's going to be an ever-going change based on the findings that are contributing when you actually first pull that oil out, whether you assess, your filters, whether you understand, wow, this, varnish has plated onto the metal surface. We actually need a more invasive absorption media to get rid of the varnish, things like that. And those are just a couple examples. And then the final step would be to evaluate the shutdown post. After all those corrective measures have been made, then you can reassess and get better for the next upcoming shutdown as well.
All right. Anything you want to add to that, Jim?
Well, and Robert brings up a great point about the documentation, because at the end of the day, and the turbine gets filled, you've got a good piece of paper that said, here's what we did, here's what we saw, and here's our expectations. So other than that, oftentimes, and I know Robert knows this, and so does Greg, that when you're talking to a customer about, well, what was done at the last change or the last overhaul, nobody knows. They just think it went from oil A to oil B, and they have no detail about how that happened. And then with Robert and good flush companies, they'll have a detailed checklist, and they'll also understand that changes happen, right? Oh, we couldn't get that valve open. We couldn't break that flange. We couldn't do this or whatever. And you just document it. It doesn't stop the process. You document that we couldn't get 8 hours of flushing in. We could only get 6 hours, or we went to 16 hours. That's all well and good. You just document it, and then you know.
Mm-hmm. And that's extremely important, Jim, because what we learn with turnarounds is that we're there to learn, and we're there to put things in place for the future. So after the first turnaround, then you realize, okay, well, we were only able to plan for 6 hours, only able to get 6 hours of flushing in. So next time we can plan for 8 hours. Next time we can plan for 16 hours. So I love that. I love the conversation. I'm just going to jump in very quickly with a question here that Greg already answered. But William is asking, how do you drain the oil after the solvancer flush? So I know Greg answered it in the chat a little bit, but I'm going to just bring it to the table because we have the experts here. So, Greg, I know you want, maybe you can start off with it and we'll jump into Jim afterwards.
Sure. Yeah. So if you do a solvencer flush, that basically that's inferring that you're trying to decontaminate the lube oil system in between oil changes. So in that case, you would, as Jim said, you probably use a 5% treat rate of mobile solvencer, and then after a month prior to the outage, you add mobile solvencer in, and then simply drain the oil and then recharge the system. There is another application where you can put mobile solvencer in long term for deposit control. To provide long-term deposit control as well. We would not call that a solvencer flush. So in that case, that could be a long-term application.
Okay, passing it to Jim.
I'll offer that on certain turbines, like in particular, like the GE Frame 7 FAs, that there are so many of these turbines in the market in US and Canada, and we've gotten a lot of skill at the conversions and that kind of thing. And one element we talk about is like the 19 low point drains on a GE Frame 7 FA. So you're going to all these low points, and then it's a conversation with the customer, like, do you feel comfortable with breaking this flange right here, putting a 5-gallon bucket? And that helps, because it is beneficial to get the residual oil out as best you can without also being practical about it. But so those 19 low point drains, and we could talk to you about that in detail later, and or the use of shop vac in different areas where you're pulling a vacuum on and you're using squeegees. Maybe you've got confined space entry with people in the tanks doing hand wiping. A lot of that is dependent upon your schedule and also your concern about severity of the previous oil. So there's some decision making in advance. And then, even as Robert pointed out, once you get into that reservoir, maybe you're making a game day decision because things are a lot worse than you thought, and we better do X. And so that's why you bring in companies that have a good track record and a long history of understanding what option A, B, and C might be.
I'm
going to just add one quick point to what Jim said here. Confined space tank cleaning and manually cleaning out the tanks, it's not it's probably not considered a really a job that a lot of people want to do, but there can be a tremendous amount of value in doing that. So if you are doing confined space tank cleaning, take pictures of the inside of the components, and if you find deposits, capture those deposits. And so many times we see, we'll see pictures of all of this varnish and deposits, and they'll have all sorts of really interesting pictures. But it would be so valuable if we could actually take that deposit and actually do some characterization and analysis on it, and figure out actually what are the mechanisms that created that deposit. So I really view confined space tank cleaning as a super high value activity that instead, in addition to just decontaminating and cleaning the system up, you're playing detective, and you have an opportunity to really capture any strange things that you see. So take advantage of that during an outage.
Definitely. Anything you want to add to that, Robert?
Yeah, I would agree 100%. I think when anyone is planning an outage, the confined space tank cleaning is going to be your utmost, biggest physical representation of what is in your tank, because obviously the oil is doing what it's supposed to do with the ad packs. It's supposed to be carrying out all these contaminants out to the path of least resistance, and it's going to settle out in your bulk tank. Apart from that, maybe identifying a couple key locations as well besides the bulk tank, like maybe a servo valve, maybe your filter housings, maybe that GE turbine, like Jim stated, has 19 different drain points in which you really want to identify if there's more aggression on one particular drain point or another. But the confined space tank cleaning, like Greg said, is not for everyone. It is a dirty job. When we talk about dirty jobs, it's pretty up there. But it is a really good, gratifying sense that you got to the bottom of the reservoir, you identified any contaminants that are in the reservoir. What we normally do is we have a nice little collection pile, and it's usually placed out on a white lint-free rag. And those physical representations can also really educate the rest of your staff and the individuals that were not involved in that particular shutdown. It is a really good learning tool that can be used between different refineries and different customer locations, whether they have a shutdown in San Ramon, and that physical correspondence of contaminants can be relayed and educated to a refinery that takes place down here in Southern California, or anywhere else, right? And so that documentation will help contribute to educating everyone and then maybe being more efficient on the next shutdown, because obviously for every minute that the refinery or plant is down, it is costly, right? And apprehension levels go through the roof at the later stages of the shutdown because everyone's apprehensive about getting the plant up and going. And as long as you're following those key stages and the order of operations, the attention to detail, I think is everything. But the good thing is we do have a lot of technology that will help us in the decision-making processes with these, additives and solvencers. I think they really do a good job of breaking down a lot of contaminants, holding it in suspension until you can actually schedule that shutdown.
Oh yeah, definitely. And I think that's one of the things that we learned. I want to say we learned the hard way initially, just trying to get over those hurdles. And hats off to the guys that go into those places, a lot of respect for you all, a lot of respect for you all. But if you could bring us back some souvenirs with those deposits, perfect. Absolutely perfect.
One other point I was just going to offer is like setting expectations. And so sometimes we talk to them about a solvent or a system cleaner, that kind of thing. And the customer kind of maybe expects that after they run that, they go into the reservoir and it's going to look pristine, like brand new day. And it is, because you've got years and years of varnish deposits, so mostly the bathtub ring in a reservoir. And that'll be like 6 to 8 inches of where deposits will settle. And that's fine. But the idea of scrubbing so hard to get that clean again is wasted effort, because they're setting on the reservoir walls, not harming anything. And so it can be, I've had customers that were upset saying, no, I expected this to be pristine. And it's just, if you let them know going in, it won't be. But the important part is your bearings and your servo valves and the key components are clean. That's where the money is.
Good, and thanks for bringing that up, because I know a lot of customers after the flush and whatnot, that is a question that they may have. So I'm glad that you brought that up. But Peter is actually asking us, what is the reason for bypassing the bearings when you're doing a high velocity flush?
I think Robert has a flushing company, so why don't we?
We're putting Robert on the spot here.
Sure, that's a very important question, and it's a question that really needs to be interpreted when looking at a PNID or looking at the structure of that particular turbine or machinery or piece of equipment, because the reason why we bypass bearings, the reason why we don't really want to use the auxiliary motor or any of the items that are currently on that system is that you don't want to spread those contaminants to the most critical component areas. Bearings nowadays have very strict tolerances. Obviously, if you're flushing, you need to create custom jumper kits or jumper hoses to bypass the bearings. Obviously, the inlet and return lines on those bearings will be your points of target. And basically, in order to do so, yes, it can become difficult. You might have to have some expert pipe fitters, and really spaces might be a little tight. And there might be some areas in which you do not want oil to travel. And that's why you have blinds and jumper hoses. And you can also have measurement tools based on those jump kits. Those contaminants are measured in 100 mesh screens that are placed directly at those critical component points. So you can actually, during the flush and during that process, you can work your way down from dirtier screens to cleaner screens. So that's the major reason why we bypass bearings is because they have strict tolerances, and you really don't want any of those contaminants to go into those critical components.
Okay, that's a good answer, and I love the fact that you answered. That was a question I was thinking about as well. So thank you for answering that. Greg, anything you want to add to that, or Jim?
I was going to say that you also need the high velocity. And so by jumpering the bearings, basically the velocities you're looking at are like 4 times nominal velocity or Reynolds number of 20,000. So the jump of that bearing helps improve that velocity. And the other thing that I know Robert knows is that we can put, they call them flushing blocks on the hydraulic system. So it's a way of flushing the hydraulic system. You basically pull off the servo valve and put a flushing block on. It's about the size of a deck of cards, and it allows for high velocities through the hydraulic system.
Nice. So
yeah, that's an excellent point. I think one other additional item to keep in mind is a contributing factor when you're executing a flush. You have to have heat. A lot of other customers say, can we execute this basically shooting a high velocity of oil through the system? Really, the heat is the contributor. Really, the pipes start being receptive to the oil starts performing the way it's supposed to. And actually, a lot of that debris, along with that Reynolds number, making sure the inner pipe diameter is completely filled. There is a lot of key factors into it. That's why you really want to choose carefully on whom is going to be touching your equipment, how they're going to be touching it, go over a sequence of events, possible failures and critical component points in which you can assess whether it's a complete job. It's got to be from A to Z, making sure the most amount of pipes are flushed, and making sure that the other factor would be that your filter chambers are empty when you do so, because that's the other part of it, is when you're flushing, your filter chambers might start catching, if you have filters in there, some of those contaminants, and you really want those to be measured on a 100 mesh screen at the end of the day. Yeah.
Nice. Greg, are you adding anything to that, or?
No, I don't have anything else. That's perfect answer. I do have a question for Robert and Jim. So just getting back to confined space tank cleaning and your little lint-free rag collection of debris. What are the craziest things you have found in the bottom of a lube oil reservoir?
You have to think about that for a bit.
I found bird feathers, a lot of pens, and but you can see if you have your pen in your pocket and you're leaning over the top of the reservoir. It's sometimes cell phones, but yeah, we've seen all sorts of crazy things, I think, on
we find all kinds of items. Pens is very common. I think some tools that are perfectly intact. I mean, we recently did a flush out in the desert where we found a wrench that was there for about 20 plus years, perfectly intact, and the operator that was on site recognized that tool. There's a variety of items besides the bird feathers, besides RTB and other electricians work, because they're doing work on the top of the turbine deck possibly, and then a lot of that stuff just depending on how clean they are will drop into FME, and so there's a variety of items that are found.
Yeah.
And I guess it's not so exotic, but you'll see epoxy paint peel off. And so not exotic, but that's I see a lot of that.
Yeah, I think we found a grease gun once. An entire grease gun. The entire thing intact. I guess they're not going to be using that anymore. But a lot of things happen during these turnarounds. So I think if you're going into a turnaround, know that there are going to be changes. There are going to be crazy calls. Just prepare yourself for
here's one thing to throw out too is some people on those turnarounds, crazy things, all that kind of stuff, is they take a shortcut and they'll use silicone as a gasket material. as opposed to what they're supposed to be using. And then that silicon makes its way into the oil and then plugs filters. And so silicon definitely is a big no-no, but I understand why people do it because they can't get the right gasket.
Agreed. And we actually had a question from Ahmed to you, Jim. He asked about the mobile system cleaner flush. Is it different for different OEM turbines, or is it one only which you can apply to all of the different OEMs?
So we really recommend this primarily in the only when needed, let's say. And so for years, this was the only hammer we had. But now we've got, they say when all you have is a hammer, everything looks like a nail. Yes. So that's where we were for years. We would always just mobile system cleaner, and the one. So it's very good when needed, and there's a lot of times when it's not, that level of cleaning isn't needed, because the big negative on it will hurt the demulsibility of the following charge. So we try not to, especially in steam turbines where demulsibility is of a key characteristic, we try not to have to use that mobile system cleaner. But sometimes there are times where that system is so fouled that we're convinced that a mobile solvencer isn't going to get the job done. And the customer knows that, okay, I am willing to sacrifice demulsibility. We do feel comfortable that if we get the mobile system cleaner down to a 0.1%, so it goes in at, let's say, 7%, you've got to get it down to 0.1%. So that's a very, very thorough displacement flush. And if you do that, then you're going to be in good shape. But the trick is, you may have plans and you think you can get to 0.1%. And at the end of the day, I mentioned like the 19-point low point drains. Maybe there was 21 and we missed some spots. And now we've hurt ourselves. So anyway, I would say by and large, the mobile system cleaner is good on gas turbines. The other thing is you don't want to run continuously with it. Kind of like our chart here shows. We don't want to use that mobile system cleaner under operation. It's going to oxidize the oil prematurely. It's going to cause additional deposits later. It's going to hurt foam and demulsibility. So you put that good cleaner in there, but then you've got to get it out. And then that's the beauty of the solvencer is, hey, even if you've got some residual, maybe it's actually a benefit to you.
Okay, that makes sense. I like that train of thought, because I think a lot of times people struggle with going back to the question, what do we use and how do we use it? So great insight there in terms of getting it from 7 to 0.1%. Like that's a lot of things you need to do before you get there. So I'm just, I know we have at least 15 minutes left in our panel. Any questions that you all have for these experts on, preparing a system for any sort of turnarounds, please drop them in the chat. We will try and get to them. But I know a lot of times when we're getting ready for these turnarounds, one of the questions that we get asked a lot is that, how do you know that your oil is ready to be changed? Like, do you allow your oil to go on to the next turnaround? Can it last that long? What can you do in that situation?
See, I'm just wondering I think there's I think this is probably the best slide that Jim put together on that.
What are your limits involved?
Yeah, I'll kind of start it again. Remember all those 7 criteria, and then you're deciding, okay, where do we think we are, and can we? So in the oil business, we're always very proud of our oils, and we always think, and I'm always trying to talk customers into, hey, I think you got another 30,000 hours on this oil. But they're saying, look, I need reliability. And we have proof of performance. They're like, I can't do this for your benefit so you can have a higher proof of performance. Because if I have a trip, that's $100,000, or in our, especially in our own plants, in our refineries, we're talking $1 million a day. And so they are very conservative. And so you'd certainly, from the oil side and also just kind of the sustainability side, we like the idea of getting as long a service as possible. But at the end of the day, the customer says, look, reliability is number one.
Mhm.
So with all that in effect, then you look at these tests, you look at all the other criteria, and you make a decision. Hey, can I make it another 18 months, another 24 months? And that really dictates, whether you're going to change or not. Or other ideas, bleed and feed, pull some out, put some in. Those kind of ideas can be generated.
Yeah, I would agree. I also think there are case studies, obviously, on a lot of the items that Jim and Greg are presenting on. The solvencers, the additives, the items that are being presented obviously have been through thorough tests, and direct applicable knowledge can be passed down on various case studies, whether it's a GE turbine, whether it's another application in a different machinery. I would lean on the experts. I would lean on the data to actually help you make the best decision. Obviously, the starting point for me would be the oil analysis, and it's got to be comprehensive. Like Jim stated, it can't just be based on viscosity or on your base stock, but your wear metals, the ad pack, the type of oil, and the stress that you're putting on that oil will also determine a lot. The operating temperature and the ranges. I've noticed a big trend in varnish recently, and that is because a lot of the cooler applications on a lot of these turbines and a lot of these systems are not keeping up with the temperature regulation. So obviously your oil is working hotter, it's working harder than it's ever had in the past, all because someone has designed a new cool state-of-the-art cooler system, but that cooler is having trouble keeping up. So those are all contributing factors, but I would, when making a tough decision, you really want to surround yourself with facts, with data, and that's going to help you kind of put yourself in a successful position, because otherwise you're going to be having a shutdown pretty quickly, and it's going to be unexpected, and it's because of a particular reason. Yeah.
Oh, yeah, definitely. Anything you want to add to that, Greg?
Well, I want to bring up just one point that Robert brought up at the beginning of this. And, I think one thing that if you go through all your oil analysis and your antioxidants are still healthy, it looks like you have longer life in your oil, but you have a high varnish potential. Operationally, you've seen no issues with varnish whatsoever. One of the points that Robert brought up was what happens to that oil during the outage. So you may have an oil that you've decided still has extended life, and you're going to keep it in there during the outage. And so if you're out for a couple weeks and now this oil has cooled down to room temperature or to ambient temperature, all of these deposits that are in the oil, they may have been in solution while you're operating, and now they've all come out of solution. So when you come back online now, your valves may be sticking. You may have a whole host of issues that you didn't have, when you were operating prior to the outage. So I think I just wanted to bring up Robert's point, considering what's going to happen actually when you bring the system down to the oil. Even if you're not doing an oil change, I think that's a really important point. And we've been talking a lot about turbo machineries, but this is even more relevant for other applications. If you look at some heat transfer systems, if you bring a heat transfer system down, you may never get it going again. You may literally have to look at removing pipes to get some of the deposits out of the system again. And so putting in a lot of thought into actually, if you're not doing an oil change, what's actually going to happen to the oil while it's hanging out during the outage time at ambient temperature.
Good point. Very good point. And I just have two quick questions. One from Patrick, and he's asking about, have you had success with removing varnish from coolers with the MS Cleaner Flush? Yes,
but oftentimes, as Greg was pointing out, Robert too, is when the oil gets cold and the products of oxidation come out of solution and really bind to the tubes, sometimes you give it a shot with the cleaner and see how well it does. And then, it's very easy to tell because you got delta T, changing temperature, and delta P. So if you've done a good job or not. And so sometimes you give it a shot with the mobile. And again, the mobile system cleaner is more aggressive. So you give it a shot. We have been successful, but there's been times where it was so foul that wasn't going to get the job done. And now you're into the mechanical where you're kind of using a drill type device to actually etch out the deposits in a manual basis.
Oh boy, that does not sound very pretty. But moving on, we have another question from.
I just put a slide up that I don't think it's sharing on the screen. Are you able to?
Hang on, let me get.
There we go. I just wanted to show this just for a moment that there are, in fact, we do have some cases where we've added mobile solvencer to a system. In this case, we don't have a lot of customers that put a dirty heater cooler bundle back into the oil typically, but in this case, this was a compressor and they had a chance actually they wanted to measure what will mobile solvencer do. And so this is kind of before and 30 days after having mobile solvencer in the product. You could see, these, as Jim said, this is not pristine, shiny metal, but a lot of the deposits have been removed. So I just wanted to make the point that it can be successful at removing some of these deposits.
That's a really good slide. Picture says 1,000 words. But jumping into this comment from Thanaraj, who is joining us from Singapore, so it is almost 1 a.m. on his side. What is the main flushing fluid used? It's a bit of a loaded question. So let's start with that part first. What is the main flushing fluid used?
I'll offer just that we always recommend the same quality of the final fill oil. So that's where you start. Certain OEMs are adamant about that. It must be, in particular, like MHI says you cannot use anything other than the same quality of the final fill product. And that's all well and good. And that's kind of your optimum recommendation. But customers will look at the budget side of things, the economic side of things. They say, okay, could I go with something less expensive? And the answer is yes. And then there's a different ideas. And so you could go with like a pure base oil. And then so we have products that we sell that are actually pure base oil. It's our heat transfer oils. We have a product like Mobile Therm 603 that is just a pure base oil, or other suppliers have just pure base oils. But that is a way to go to reduce your cost, is to use a pure base oil. We don't like we know that when two oils come together, there can be an additive interaction, especially with the antioxidants, and they can fight each other. So we get very nervous, and as long as we understand, okay, this oil and this oil, and they're well known, no issues. But sometimes another oil meeting up with the final fill oil can be problematic on the final charge.
I'm just jumping into Robert and Greg. Anything you all want to add to that before I move to the other questions in the comments?
Yeah, I would agree with Jim 100%. Really, the rule of thumb would be to use the exact existing oil that is projected for that application. Now, if it's for a fiscal reason that you want to water it down a bit and use more of a base oil, 100% okay, and it is satisfactory to do so. Keep in mind when doing a flush, the overall purpose is to really clean up that oil at the same time. You have heat, you have velocity, and you also have filtration. The cleaner the oil is, running into that system and cleaning the pipes and all the important areas, and then collecting that measurement tool at the end, it's really going to be vital. So honestly, yeah, it'd be great to use the existing oil or a sacrificial oil and then throw that out and then get to your new fill and try to really drop isocode significantly on the initial fill of the new oil. It's going to help it give it a head start when starting up.
All right. Anything from you, Greg?
Well, I'll just point out, hey, Jim.
I seem to have gone sideways on you.
I'll just point out in other parts of the world, we have heard about some crazy things that are used for flushing. And maybe the craziest flushing medium I've heard is diesel fuel used as a flushing medium for flushing out, turbines. And I would discourage that.
Yes,
I would say,
highly.
please stick with what Jim and Robert have said.
Definitely. And Raj is actually getting into what is the temperature and pressure used. I feel like this varies per system, but I'm leaving it to the experts on that. Anybody want to tackle that part of the question?
Sure. It really depends on the machinery and equipment that you're flushing. There is an OEM spec, and then also in most cases, the manufacturer has a determined target that needs to be adhered to very stringently upon the flushing stages. There are a couple areas where the oil is going to keep up with any temperature you're going to throw at it. Normal ranges for any temperature for a flush would range anywhere from 120 degrees to maybe exceeding 150 degrees. The pressures also are really determined on the equipment being used and the pipes that are being flushed. Obviously, in bigger applications where you're flushing a big steam turbine, obviously, you might have differential pressure on some of the equipment being used, and that's a good measurement tool. But the PSIs usually will not exceed, depending on the application, 120 PSI. But there is an optimum range on the equipment that you're using to flush to actually give you a good parameter in which to stick to. And also, when you see those high PSI ranges, obviously they're for reasons. They're for specific reasons. You're catching specific contaminants that are causing a drag on the oil being flushed through the system. So that's something you really want to pay attention to, even when commissioning the unit back up and actually placing new filters into your unit and actually getting on turning gear or actually operating. You really want to listen to your system. You want to lean on your operators that have been on that unit every single day, day in and day out. See if there's adverse change, if there's something that is abnormal, because usually in most cases, if they identify it, they'll identify it very quickly,
Always use your boots on the ground. They are the ones that are around the equipment the most. I just want to jump into one more question because I know we have 3 minutes remaining. It's coming in from Peter, and he's asking, when solvents is used for long-term deposit control, how does the oil behave when it's cooled down during the outage with respect to keeping the varnish in solution? So I'm going to drop that in. Greg, what are your thoughts on that one?
Sure. So, one simple analogy for thinking about how mobile solvents impact the oil. It's like the oil has a natural bucket to hold things. A Group 1 oil has a slightly larger bucket than maybe a Group 2 oil. If you add mobile solvents, now you have this huge bucket and can hold all sorts of degradation products. That's why you see the MPC number dropping quickly when the oil's cooled. Traditionally, you would see these things coming out of solution. Mobile solvents will keep them in solution. So as a result, you'll see a lower MPC value, but even more importantly, during an outage, you won't see these deposits coming out of solution.
That's very
question,
good.
Peter.
Jumping to Jim, anything you want to add to that?
Yeah, just like the size of the unit, like again, like a GE Frame 7 FA holds 6,200 gallons. So now you've got 6,200 gallons to hold all those deposits. And the deposits that we'll see like in a last chance filter or in a servo valve, they're small. I mean, it's less than in a handful. So that is put back in the solution. And then when that oil cools, that's the beauty of it, because it is a base stock. So it helps hold those products of oxidations in solution even when you cool it.
All right. Anything you want to add to that, Robert?
No, I think you guys have it covered pretty well.
I just have one more very quick question from Raj again. He's wanting to find out how many times is it required to flush a system. And I think that highly depends on the system and what you have going on inside of it. But I'm leaving it to you all. Jim, we're putting you on the spot, starting off with you.
You're right. It's answering those 7 questions in the beginning helps dictate this. But if you do it right, it's once.
Okay, good.
And I think if you have a flushing business like Robert, it's many, many, many times.
Well, you're right. It is nice to be pretty busy. I think a lot of our business model is based on relationships, honestly. We've had multiple referrals, and it's a lot by word of mouth, but honestly, it's based on the success rate. So if you do a flush correctly, yes, once is the optimum target. You're hoping that the customer doesn't have to incur that same, situation, in the near future. But at the same time, you want to make sure that it is strategically and fiscally responsible to execute those things, because these things are invasive. You got to make sure you have the right personnel on your equipment, because they can adversely really change when your system goes back up into operation. Adversely, all those changes, the flanges, the attention to detail, and all the pipe commissioning back up could have a very adverse effect on the actual system. So obviously the answer would be based on the data. When the data tells you that you actually need a flush, there's a lot of systems that actually tend to have a lot of scoring on the bearings. And that happens very frequently because nowadays our PM intervals are being extended. We're asking our pieces of equipment to run harder and produce more power than they have in the past. And it could be for a variety of factors. Maybe the parent company does not want to shut down. Maybe they want to extend the interval, which obviously in any maintenance strategy, it's going to affect your equipment that much more. So it really just depends on the data you're gathering between the oil analysis, your PM schedules, the sequence of events when doing your PM schedules and your confined space tank cleanings. Those are the things that are going to contribute to helping you make that decision.
All right, I think very well answered. Just a quick question. I know Greg already answered this in the chat as we're closing off. Thanraj is asking if mobile solvents is compatible with mixed lubricants, groups 1, 2, 3, and 4. I'm thinking that's 3. Yeah. So
the easy answer is yes. Yeah. The more complex answer is that our experience is really on non-detergent based formulations. So we don't have a lot of experience putting this, say, in engine oils, so I would say I'd probably feel a little more comfortable doing some more work on detergent-based formulations first. But in non-detergent-based formulations, group 1, 2, 3, and 4 is all compatible.
All right. Anything from you with that, Jim?
No, but Greg and I are talking about working on engine oils as well too. So that's future work.
Interesting. Very interesting.
Next panel to be.
Next panel, yeah, next LRVS. But we're coming to the end of the session. We're a little bit 3 minutes over time. But thank you all so much for sharing your knowledge with us. And I know our LRVSs, that's a tongue twister. Our LRVSs always join us in from all different parts of the world. I know Thanraj is coming in from Singapore and it's 1 a.m. on his side. So thank you for staying up. So with us, and we have on the other side of the world going back, all the way back to the Americas. So I want to thank you all so much for being with us and sharing your knowledge. Jim, a lot of information that we learned from you. Robert, very good information. And Greg, I always love talking to you. So that's always a pleasure. So we are going to be getting ready for our next LRVS. I believe it's for the APAC region. So, look out for things that are coming, things that are going to happen soon. But thank you all so much for joining us. The recordings are going to be available online. It's already up on YouTube and LinkedIn. And we will be reaching out to you with more information. So stay tuned for our next LRVS. And thank you all so much for taking the time out of your day in all the different parts of the world just to have these sessions with us. All right. Thank you all so much. Bye.
Thank you.
All right,
Thanks
bye.
so much. Bye bye.
Thank you.